than the last time I was here. So, okay, so I'm going to talk about a subject that in theory doesn't need to be talked about anymore, which is the subject of IPv6. And yet, I've been talking about IPv6 now for many, many, many years. For a subject that started to show up as being an interest, at least on my side, 12, 13 years ago, it is interesting that we still have discussions today about bringing v6 into play on IP backbones, internet exchanges, or users of internet exchanges, and obviously out towards the end customer. But because I work for a company that focuses on backbones, on moving large amounts of internet bits around the world, I'm actually going to only focus on the things that touch internet exchanges, the interconnection of backbones, the ability for one backbone to talk to another. And I'm actually, when I sort of thought about talking about this today, I realized that I also wanted to make sure that I provided some useful information that was relevant to the region here. So I'm going to run through a bunch of interesting stats in this. I'm going to talk about, as I said, v6 at the backbone. If you want to ask me about IPv6 on a cable modem or a DSL line, I'm the wrong guy. Not my subject. There are others here that do. Yeah. So I'm going to, as I said, I'm going to look at what's going on globally. I'm going to look a little locally, and I'm going to talk a little bit about sort of, some of the methods that we've used for the future. I'm going to skip a slide just to give you an idea of who I am. And I normally don't do this because I'm not a marketing guy. I'm truly I'm a networking guy. But I work for this company that runs an IP backbone that stretches out throughout Europe, the United States, and Asia. We've been in business 19 years. We are based in Silicon Valley. We started literally with one web server and grew up from a web hosting company, a data center company, to running a global backbone. We peer at an enormous amount of internet exchanges. And key point about that is that we have a lot of internet peering experience. And we run v6 everywhere. By default, everything is enabled v6. And I realized I wanted to sort of throw that marketing comment out, even though I'm not a marketing person, and the like. Okay, so where were we? So let's show some graphs. Let's sort of get some ideas on where we are numbers-wise, because this sort of gives us an idea. So the first thing I'm going to do is sort of show you a nice graph that goes up, but it's not an up-to-date graph. It's about 4 months old. I'm going to tell you what happens in the next 4 or 5 months in a moment. I'm going to repeat this story a couple of times. The Internet Society, thank you, put together 2 events in 2011 and 2012 to promote IPv6. We had spent a lot of time as individuals saying we need to do v6, but no one forced that to really happen. In 2011, we ran World v6 Day, a 24-hour period. I normally would say, hands up everybody that has heard about this, but it's too close after lunch. We haven't comatosed yet. I'll check whether you're there. But there's actually a key point about this and why this graph is sort of a useful graph, is that 4 months before that, 5 months before that, was when IANA, the source of v4 addresses to the routing registries, officially ran out of v4, handed out the last set of v4. And this event, which we all knew was going to happen, because it happened, meant that the popular press, the New York Times, the Wall Street Journal if you're in the United States, the Guardian in the UK, Europe, all different magazines, news magazines in Europe, in Asia, around the world, said, wait a second, we've run out of numbers? This is like running out of telephone numbers. They got the analogy because it was actually an event that happened. Instead of a bunch of geeks saying, this will happen, that had no effect. That single event, which then helped prompt World v6 Day, a 24-hour test of v6 globally, started to make this graph, which I'll explain what it is, start to rise. Now, this graph is a measure of autonomous system numbers, AS numbers, the building blocks of backbones, what we peer with, what we build with, what we move bits around with. And this is a graph that counts the number of them that run v6 versus the number that run at all, normally just v4 by default. If you take this graph all the way back to 2008, 3.5%, pretty pathetic. When you look at what happens here, we suddenly get this knee in the graph. This was a great event to trigger people into realizing v6 was a good idea. But look what happened right after. By the way, it was a very successful day, but ignore that point for the moment. Look what happened right afterwards. Dulls down. And the reason is that human nature just won't take anything seriously unless there's a deadline. Now, if you've got teenage kids doing homework at school, you understand this. Because Sunday night is when homework gets, you've had it for a week, doesn't matter. Until you have to hand it in the next morning, nothing happens. Now, the other excuse is that it's Europe and everybody went on vacation. But hold off on that for the moment. A year later, World v6 launch. This says something different. Turn on v6, leave v6 on. This had a secondary effect. It wasn't a particular day to turn things on. It was a turn on by that day. And again, we see this nice rise, and it languishes, you know, at sort of a standard rate after that. What happens to this graph afterwards is nothing. This graph looks better if I show this version. Because if I continue the graph for another 5 months and show you that it's only sitting at 17%, 1% more than June of this year, the graph looks pretty bad. And you could claim that it's a simple reason. There's no gun to somebody's head. There's no deadline. People aren't looking at what to do next. And that's sort of the story of v6's push through the world over that much length of time. Let me look at a couple of other graphs, because that was just a graph of the number of autonomous systems, the number of backbones that were enabled. Now look what happens at the bandwidth level. So this is a bandwidth graph, and prior to World v6 Day, we're talking minuscule amounts of bandwidth. But on that day alone, we saw enough of a jump. It lasted for 24 hours. But a few websites said, hey, this works. This v6 thing actually works. We'll leave it running. Over the next year, from June of 2011 to June of 2012, with the decision to do this World v6 launch date, the graph started to head upwards. Now, part of what happened was that sites started to enable more and more of their website, not just the textual side, but the graphical side. When you have people like Facebook adding their back-end websites like api.facebook.com. If you've got Facebook on a smartphone, you aren't actually going to www.facebook.com. You're just doing a bunch of XML queries against the API. And when they enabled that, and when certain mobile phone operators enabled v6, that started to see the rise. But also what happened was that was enough of a hit that people realized this v6 thing really worked. And over the next year or so, although this graph looks fairly ragged, the reality is it's measured on our backbone. And we aren't the world. We are just one measure of many. So it's, as long as it keeps sort of going up, then we're okay. And in fact, actually, if I sort of zoom up to today, you'll sort of notice that as much as you see things like this happen, it just is continuing to rise. Overall, large amounts of bandwidth. There are some great stats available from other companies. So, you know, this is not bad, but percentage-wise, traffic-wise, this is absolutely nothing. That's the other slight point. So let's show something that's a bit of a problem, because you know we all like problems. We walk away remembering problems. So this is a protocol called Teredo. I could ask if anybody still has got Windows XP sitting on their laptop, but I would not recommend you to put your hand up and admit it in public. Microsoft built this protocol called Teredo that enabled v6 connectivity through a v4 network. It's pretty clever. It's been around for a long time, and it won't die. So Microsoft turned around after much discussion and decided in July of this year they would do a 7-day test. They would turn off the servers that help this traffic, and we'll measure on backbones we'll measure whether anybody complains and see what happens. And what's interesting here is there's a nice little long tail drop in traffic levels, and that sort of made sense because it turns out you only need the servers to kick off a connection. After that, you don't need them. But after 7 days, the theory was turn it back on and see what happens. First of all, to see if anybody complained over 7 days. Who's using this protocol? Are they going to complain, et cetera, et cetera? Look what happens the minute you turn it back on. Woof, back comes the tunnel traffic. And it comes back to exactly the same levels it was. And no one notices. So the question is, what's going on here? And it turns out nothing was lost. All that happened was that this traffic just reverted to using v4. But what was the traffic? And it turns out 90% of 99%, maybe 99.9% of all this traffic was BitTorrent, which is very good at finding another way of getting bits. And so it's very unclear what Microsoft will do with this Teredo setup. It still is on today. It's still shipping the same number of bits. And what's interesting is that Microsoft just announced their new game platform, the Xbox One, and it's possible that this protocol is built into that box, which would then add even more complexity to turning it off. So not everything is perfect in the v6 world. So let's turn back to perfect, because I like perfect. Here's the classic up and to the right graph. This says we're doing everything right. This says here that the number of v6 addresses on the global routing table, all the backbones are announcing, is steadily going up. Here's the number of autonomous system numbers. But you know I said 17, we only hit 17% of autonomous system numbers running v6. And it's taken a long time to get from 16 to 17. One of the problems is people keep building new networks. And new AS numbers exist. And therefore, it's always a rising target. But the good news is it is one of those up and to the right type graphs. So this is a nice way of measuring, hey, things look good, things are happening, but these numbers are still fairly small. The number of autonomous systems that exist in the global routing table is 48,000 at the moment, and we're only at 8,000 running v6. Here, the number of total prefixes, which is not a good measure against v4 because it's actually quite nicer to do v6 announcements, easier. v4's, I think, hit basically 500,000 at this point in time. These numbers are still very low. So here's what I want to do. Go find a different way of measuring v6 and also have some fun while we're at it. Now I will ask a question. Who here has used this? We've had this tool on the web for a couple of years. bgp.he.net. Has anybody come across this website? A few happy smiling faces. Cool. Okay. It is, for those people who don't know, it's a website that we had internal to the company for years. We, about 2-3 years ago, decided to let it out to the rest of the world and use it. It's not based upon our data. It's based upon data from RIPE. Thank you very much, RIPE. And from Oregon, Oregon Route Views project in the US. We take all their data, we manipulate it, we throw it into a database, and then we start displaying it. And we display stuff like this. We display these sort of simple diagrams that say, hey, you're here, and your routes are going here, and then they're propagated through someone else, and then they're finally sent through another place to their destination. And we draw this sort of nice, simple diagram that shows route propagation. It's meant to be visually easy. If you're a network engineer, show this to your executive management, and they may understand the internet. It is meant to be a tool that can be used by network engineers, but also have executive management go, ooh, pretty.
And Martin, anyone can look at this.
Sorry, and it's totally open. Anybody can look at it.
Not a secret.
Yeah, it's absolutely not a secret. A bunch of words about how it works, but you know, these slides are online, and I'll skip all this. But the bottom line is, it's built on work that other people did, collecting the data. We did the visualization. There's different types of visualization. Vesna will show you the right visualization, which I'll explain. There's one very key difference. we only publish a snapshot once a day of our data. The data that if you go to the RIPE tools that Vesna will talk about tomorrow, that's live. You can see it real time, or as real time as anything can be, and it's meant to be different. But we can do this. We can look at data for a particular country based on a country code that's sitting inside an RIR inside a registry. We can also go look for any particular network. Who are they peering with? Who do we see BGP connections with? We can look at their backbone, and we can look at it for v4, and we can look at it for v6, and we can start doing a comparison of what v4 and v6 is. And so we built tools to do that. And we can go and then even look at any country and sort of look by the number of adjacencies to turn around and see who has more BGP peering. And then we can start merging that whole thing together and build graphs. Now, the graph I showed you originally was for one service provider. Here are the routes, and they flitter off to the rest of the internet. What we could then do is turn that all the way around and say, hey, let's take a whole country. Let's look at every service provider, and let's see how they interconnect. And let's see whether we can actually see a difference between the v4 interconnects and the v6 interconnects. You are here. This is what Serbia looks like about 2 hours or 3 hours ago, or whenever I dumped this data. You're not really meant to be able to read all the text on this, although on the uploaded file you should be able to. So let me explain what we did. The internet's big, really big. So we put it all in this box right in the middle there. Except for every autonomous system number that exists that's registered to Serbia. If it's an AS number in London, UK, it's not on this graph. If it's in Germany, it's not on this graph. And what we end up with is we sort of see these hot spots here with lots of lines coming out of them. And we see a couple more over here and a few others. So I can actually read that you know, this is Telecom Serbia. No surprise there. Here's SBB. Maybe no surprise there either. I don't know who this guy is, or this one, but I can tell you from the basic logic, this is sort of a simple, single-homed AS somewhere inside the country. Here's somebody who's multi-homed. We see a couple of lines coming out of them. And the same here. This guy is a couple of lines out of it. And what we really see here, which is interesting, is there are lots of lines heading to the rest of the world. So that means there's lots of players that have some form of BGP connectivity out of the country to a neighboring country, or maybe they go hell and beyond off to Frankfurt or London or even further. The ones that are green here, they're the ones that are only connected inside the country. The ones that are, well, it's a really poor color. It looks better on my laptop. These are sort of very pinkish reddish, but it doesn't show up on the screen very well. That shows they've got connectivity to the rest of the world. Now, all these blue lines are really interesting, but they're not good if you're a v6 guy. They're good if you're an internet person. See a red line there and another red line there, and there's a few others in here. They're sort of hard to see. They're the lines where there's v4 and v6, because blue here means there's v4 and only v4. So we have to look at this diagram a little differently. Here's the v6 connectivity for all the AS numbers in Serbia. It's type kind of sparse. And I'm being polite. Now, I know that Telecom Serbia and SBB, where are they? There. And there's a few others here. And there's a good handful. And I'm not going to show some of the stats that I think that I'm not going to spoil the stats for on some of the ripeness numbers that you'll see tomorrow. But this is pretty sparse here. But remember, all I talk about is v6 at the backbone. I'm not measuring whether anybody has a v6 customer here. Not my concern. Not my concern. What I'm concerned about is whether the backbone has it. And whether the backbone has it means, is there connections to transits that have been enabled for v6? Are there routes being anchored, ready to use? Is there any form of peering between players that exists with v6? So we see a few interesting interconnects here. I can definitely say that this guy, whoever this is a v6 customer of, well, this is Telecom Serbia, who then connects to many people, but also the rest of the world. There's just not enough lines on this graph. So it turns out if I'm going to continue doing this and continue sort of displaying this information, I'm just not going to have a great presentation, because the reality is there's just not enough stuff going on in the v6 world. So I can fix that by not talking about it. I can do it differently. Let's look at some of the surrounding countries here. You will see a couple of colored lines. Sorry, the projector really can't show this very well. But for these number of ASs that exist in Albania that are registered, maybe don't exist, but they're registered. As best as I can tell, they're in Albania. Much simpler. We have a core set of networks that definitely connect outside of the country, and then we have a few multi-homed players there. So I mean, just flip back for a second here. That's the complexity of Serbia, and I don't think anybody is surprised. Smaller country, less ASs. Moving on. Bosnia Herzegovina. Again, fairly simple. Definitely quite a few connections out. But again, I can see them up here. You know, there's like 1, 2, 3, 4, 5 connections that are v6 related compared to the rest. The numbers aren't looking good, guys. Got to get better. Croatia, lots of networks. Trust me, the reason I didn't put the separate graphs on here was because they were looking pretty slim. But you can see a few reds in here, but the rest of this is all blue. There's somebody out there running v6. There's definitely people providing v6 transit on these graphs, but there aren't that many down here. And the point is that this isn't unnatural, which is a bit sad. That 17% that I talked about really does manifest itself in graphs like this, which are really fun to look at, but if you're a v6 person, they're kind of sad. Not many networks in Montenegro. Nothing else to say about that. Yeah, Macedonia. You know, we're running through you know where I'm going with all this data. Okay, but there we go. Don't you love those guys in Slovenia? There's a fair amount of v6 in Slovenia, but you're going to hear a lot more about that from other people than from me. The bottom line out of this is actually there's a lot of connectivity in and out of the country out of Slovenia. It's easier to get to Austria. It's easier to get to other places. You definitely see dominant players here. Where's the other one? There. So, you know, but you see a little bit of red over here, but this graph would have been worth showing. There's actually more going on in the v6 world, but Vesna, you are going to show all the ripe stats for this region, right? So I don't want to break. I don't want to.
Yeah, don't worry.
I'm not. I don't want to spoil.
No, it's fine. I will actually only show some for Serbia.
Okay.
Leave the rest.
Okay. Moldova.
Careful, my old country.
Oh, sorry. That's. Yeah, Jane has spent time in there. Actually,
this is way better than it used to be.
it's way better than it used to be.
Yeah.
Look, there's actually multiple networks in Moldova. Okay.
But you have lots of single home ISs.
There's lots of single home stuff going on here. There's lots of dominant. This is Orange, you know,
Yeah.
the France Telecom guys and the like. So, you know, again, these graphs sort of make sense, but they're still pretty low in the v6 world. Then there's Romania. There will be a test on this graph later. There's a lot of AS numbers in Romania. There is a lot of AS numbers in Romania. There isn't that much v6 outside of, well, so there's an interesting exception here. if you grab these online off the Internet Society website, you'll be able to zoom in and see who's who. But you'll see, I think this is RCS RDS, who are really a big player. They have actually turned an enormous amount of V6 onto their DSL base. They've done a very good job. But what's interesting is, now shows a slight flaw in showing this type of diagrams. These talk about ASs, they talk about backbones. We're here talking about internet peering, so I talk about backbones, not about the amount of traffic. But anyway, this is Romania. Not to be outdone, but slightly smaller country. Bulgaria, you know, this is an awful lot of ASs considering the land mass of the country. But there's some V6 hidden in here. There's just not enough again. And again, we're dealing with this small network. All right, I got one more to show. Interestingly enough, Hungary, which actually has got, in theory, a lot more going on, there's something subtle about this graph which is sort of interesting. There's an enormous amount of connectivity to the rest of the world. And that's because Hungary is a lot closer to some of the international peering points. And there's a lot more use of Western or European or US service providers as transit providers than in some of the other diagrams. Okay, last graph, because it's sort of the fun one. So what happens if you take all of those graphs and you zap them into just one circle and look at which country connects to which one? And after a while, although this is not set up geographically and it's not really meant to be, what you sort of notice is that the geography it sort of seems to play a certain good role here. Now, we find lots of people interconnect in places like Frankfurt or Vienna and the like, because that's BGP peering. This does not show you trace routes. It just shows you that BGP is connected. But what's interesting is, like Moldova, for example, you see connectivity to Romania and the rest of the world, but you don't see anything else. That type kind of seems to make sense. Macedonia is pretty close to Greece, and there's actually connectivity. There's actually BGP connectivity there. But it's not as easy to use this graph for much more. It's just an interesting, useful trick with BGP data. So I'm going to wrap up with a couple of comments. First of all, somewhere else. Here's Germany. One important point about Germany is the red here is the visualization of networks that connect to other networks outside of Germany. So the fact that there is an enormous amount of global networking going on in Germany means that the ratio of globally connected networks connected to somewhere else is much higher than just the localized German networks. That's sort of interesting. But there's actually a lot of V6 inside the middle of this, a lot more than in other places. But I sort of got bored at this point and didn't want to keep drawing graphs because I wanted to show something else. So there's a caveat. Is this data good? I've sort of shown you fun stuff, and the answer is this is only as good as the data collected. And what hasn't been talked about internet exchange points, which is very key, is that collecting BGP data and providing it to people like RIPE to allow it to be processed globally, openly globally, I must restate that statement, actually is a great addition to internet exchange points. Okay, so that's, and then this last point is sometimes you see connections between two countries, but they actually are going through a third. So you may see a connection from one network to another, but it's actually going, let's say, hell and beyond to Frankfurt. Okay, final point, then I'm going to shut up and sit down. Bringing it back to talk about V6 and the work that we've done at Hurricane. We did two things some of you may know about. I actually know some of you do know about. So we ran two different projects to sort of convince people to get interested in V6. Tunnel Broker we've been running for literally for years. It's about 12, 13, officially 12 or 13 years now since we first started it. Tunnel Broker was our method for getting V6 connectivity when your service provider could not give you V6, whether you're on a DSL or a cable line, or if you want to use it for BGP connections. The other one is this certification program where we've done this online testing to sort of see whether you like and know V6. And what we did was we said, hey, if you get it finished and get top marks, we'll send you a t-shirt. for free. We've shipped, I think, somewhere in the order of 8,000 T-shirts now to about anywhere in the world. And, well, I know Jan's got one. Anybody else? Has anybody else done this test online? Yeah, you don't count either.
I didn't receive the T-shirt. You get that a lot more.
I get that a lot, yeah. There's a ticket system for that. I have no access. I have no access to T-shirts, but so here's the comment. If you're a network engineer, give this a try. I've known a student in India do this test in 2.5 hours, and half of that delay time was because the village he lived in lost power. So in theory, it's quick to do. If you're a manager, get your network engineers to do that. We'll ship them a free T-shirt. We don't mind. Get your engineers to do this. But there's a trick to this test. There's a really subtle trick to this test. It's not a question and answer test. It starts off with a simple question. How many bits in an IPv6 address? Oh, 128. The easy questions. But then it says, hey, could you trace route on v6 and paste the answer into the website? And then it says something like, could you look at this web page? It's a v6 web page, and then type in the code back onto into the test. Well, to do that, you have to enable v6. You have to convince, the test is convincing you to do some action in the real world of turning up v6. And the test continues because it says, hey, we'd like to send you an email. And by the way, we're only going to send it to you over v6. So you need to enable v6 on your mail system. Oh, and we want you to send us an email. Oh, that means you've got to enable v6 for outgoing email. And this process continues and continues. Websites, name servers, DNS records. And when you've done all of that, we'll ship you a T-shirt. Motivating geeks to turn up v6 via T-shirts is a time-tested method. I mean, you can motivate geeks to do nearly anything with T-shirts. So the certification stuff, as I said, we've been running it for years. We've shipped T-shirts all over the place. Give it a try. There is actually the biggest problem we've had with people not getting their T-shirts is the problem between the keyboard and the user. It's not reading the instructions. Congratulations, you have finished the test and you have succeeded and you have top points. Now go back and tell us what shirt size you want. That one test will, if you don't type in the shirt size, we don't send you a T-shirt. Anyway, enough about that. I'm done. I'm seriously done. I'll take questions, and hopefully, if nothing else, remember I'm really focusing just on the core side of the internet, not on the edge stuff. But
can I add something?
Yeah.
In order for me to get that T-shirt, at the end you need to make a DNS Glue Records. That means your domain needs to be, your glue record needs to be on IPv6. And we actually enabled the IPv6 on a Slovenian TLD just to get me T-shirts.
The subtlety of that last test, that was why we did it. The last test had nothing to do with you. It had to do with you influencing your service providers or your DNS providers. And it is best practices these days for top-level domains, .rs, .si, even .com.net, to enable the ability to install v6 information. 2 years ago, when we started this test, that was not the case. And one of the key points was that we decided, okay, if we can motivate 1,000 people, it was the first run was about 1,000 people, with a bunch of T-shirts, maybe they'd pick up the phone and complain to their domain name supplier. And sure enough, they picked up the phone and emailed and complained, and things like that actually happened. Anyway.
So we have about 5 minutes for questions. Does anyone have a question for Martin?
About the program, the test itself, are you continuously improving, changing, adding new subjects to the test, or pretty much stable?
The test is pretty much stable at this point because it's been proven to run people through the process of getting their infrastructure on v6. So, for example, if you're sitting at a university and your university has got v6 enabled, and you've got v6 on your university website, or you've got v6 on your desktop, and you've got v6 in your email, you can just run through this test from beginning to end, maybe in 30, 40 minutes. And we're okay with that. You want a free t-shirt? Free t-shirt. Hey, it has our logo on it, so we have some value in it as well. But we haven't added more to the test. We haven't seen any need to it. Because that last part of getting the final set of infrastructure has definitely pushed a lot of people into getting v6 enabled at different parts of the infrastructure. So yeah, we haven't changed much. Yes.
All right, I understand that the technical personnel that the engineers are supposed to do tests and everything, and what about the people who are not engineers, who are just beginning to, who are just opening their ISPs, who have very little personnel who understands IPv6 and who doesn't have the training? Do you have on the same page as the test, do you have the documentation for maybe implementing with Pine9, implementing with all the other services for the hosting service and everything else? Do you have all that documentation on the site, or does the person have to search their own on Google or anywhere else?
It's a great question, actually. So let's sort of go back and remind you where we came from. We're an IP backbone. We just believe in v6. I mean, this was way early and the like. And part of what we did with Tunnel Broker was specifically help early adopters get access. And they were very techy. There's no doubt about it. This was you had to be technically savvy in order to take this to the next level. However, we added, and we're not the only people, we added forums for conversations. We added the ability to have people add answers and questions for other people that had issues. And we're not the only place. I mean, this is not meant to be our focus, a place where people could put information in there. But the majority of people just go out and search. The truth is that there's good search engines now, and it isn't hard to find stuff. That said, if you were starting fresh, actually, there's a great example of this. If you're starting fresh and learning networking, in this day and age, you should be learning v4 and v6 because the difference, the incremental difference, is so small that you would then, by nature, be doing things in a v4 and v6 world in lockstep together at every point, and you wouldn't let anything compromise that. So I spoke many years ago to a professor who taught networking at a university in Honduras in Central America. And one of the reasons why 3 years ago he started teaching his students v6 was because he wanted them to learn networking independent of v4 or v6. Everything done, as I said, in lockstep. So if you're starting fresh, it shouldn't be that you learn v4 and then wonder how to do v6. You should do both. But if you're not the technical person and you're going to hire somebody to do something, then make sure that job statement, that job description says v4 and v6 equally. Don't just do v4 and think about v6 later. There's no reason to now. Because hardware, software, the type of equipment that's being delivered today is, to the most part, v4 and v6 compatible and in sync.
So we're going to let Jan speak pretty quickly about a BCP, and he'll explain what that is. But I do want to reiterate what Martin is saying. I used to be the vice chair of the U.S. IPv6 task force for the U.S. government. This was many years ago. I was not a technical person, but one of the movers on the management side, trying to talk to the networks that were interfacing with the U.S. government networks. You have an advantage if you're learning v4 and v6 together now. You have a big advantage over countries like the United States because there's so much embedded code, so many old networks. lots to replace. And if you don't, you have an advantage over them, and you have something you can market in a different way. So many of the networks in the United States right now are trying to catch up. There's a lot of great work being done through Martin and others, and I will also make a pitch for the regional internet registries and the great work that they do to promote the deployment, and Vesna will talk about that. But Jan has put together a best common practices for RIPE? For the world, and so he's going to tell you about it.
So, hey, my name is Žorž from ISOC Deploy 360 team. It's a great question, and that's actually what I'm working on these days. We are trying to start the efforts of BCOP. It's called BCOP, Best Current Operational Practices. It differs from the BCP. So BCP are best current practices that can be written by anyone, by the wizards, magicians, philosophers, everyone. But best current operational practices can be written just by experienced operators that are doing this stuff. And for now, we created the operations task force, or BCOP task force in RIPE. I'm co-chairing it with Beno. So if you all come to the next RIPE meeting, it will be in Warsaw, in Poland. We will have the session of best current operational practices on Thursday morning. What is this all about? This is all about bringing operators together to sit and talk to each other, share the practices, and write them down. So we need documented practices, and how they can be published as a RIPE document. They can be published if at least 2 major big operators agree that this is actually the best practice. We are doing that all around the world. In NANOC, you have IP BCOP, that's now BCOP regional. In Latin America, in Caribbean, we started the LAC BCOP task force as a part of the LAC-NOG and LAC-NIC. I just came from Djibouti, from Ivory Coast. We started there the African effort. So we have regional efforts for the operators to talk to each other and document these practices. And basically, this is what you need. If you don't travel much, if you don't go to these meetings and talk to other people that much and share the best current operational practices in a hallway conversation and things like this, I understand it's quite hard to find it, because if you type in Google and say, how to implement IPv6, bang, gazillion answers, and you don't know which one is relevant and which one is not. So we are trying to put together some repositories of the best current operational practices that are relevant and that people can trust that much. And if you like, go to the RIPE.net website. You can find the BCOP mailing list. Join there, it's open.
I already have the right training for IPv6, and for buying, we already had the implementation of IPv6. I just believe that this kind of specific method for operators in general, the best method for all operators would be best to be kept in one place and for all to have access to it, because that would encourage other operators who have trouble with implementing IPv6 internet network to actually implement it.
So my long-term love is IPv6. I'm the IPv6 guy, but BCOP is not just only about IPv6. It's about any operational practice, even how to install wireless in hotels. Now, seriously, in Africa region, we received a proposal for a document how to install the Wi-Fi network in a hotel, and I agree. I travel a lot, and I completely agree. Thank you.
Well, thank you for your question, because it's a really important question. And also, for those people that are not technical but managers, it's important to promote your technical staff who want to do something interesting with the network and learn V6, because you have to help motivate them from a management perspective. And that, if that doesn't happen, it can kill their desire to do more technologically and innovate, which is something important as well. Thank you to Martin. Thank you to Jan. Awesome.